Hello everybody and welcome to our video today where we are in General Chemistry Chapter 1 Atomic Structure. Lots of fun stuff here. Definitely important for the foundation of general chemistry. So let's get into it. So this chapter covers, subatomic particles such as neutrons, protons, electrons. I'm assuming if you're watching this video, you kind of already have the gist of those things, but that is definitely mentioned in this chapter. But if you need some extra videos, definitely look those things up. Neutrons, protons, electrons, basis of our chemistry. So then we have atomic mass, which is the number of protons plus the number of neutrons, okay? That comes up in a couple of questions that I've seen during my practices. So definitely, look at that equation, just know it like the back of your hand. Then we have atomic weight, which is the average weight of certain isotopes of an element, okay? And the atomic weight is also the mass of 1 mole of that element, which is the same thing as Avogadro's number of atoms, okay? So if you have 1 mole of carbon, for example, that means you will have 6.02 times 10 to the 23 atoms of carbon in that sample, all right? And then we also have the atomic number, which is the number of protons, okay? All right, so now we will talk about Bohr's model a little bit. Again, very, very general in this aspect of things, just because these are the foundation. When we get into the equations, that's more so, the important parts of the chapter, and really the other chapters all build upon this. So even though this may seem surface level, just touching on these things, refreshing, super important. So we have Bohr's model, which, is really focused on the orbits of an atom, and this model states that the farther orbitals have increased energy, okay? So you'll hear in the next little part about quantum numbers about energy levels, and energy levels are basically the shells of the atom, all right? So the ones with the further away from the nucleus, the higher energy those electrons have, okay? So when an electron, a photon is emitted when the electron drops an energy level, okay? And then we have a photon is absorbed when the energy level increases. So if you're starting with your nucleus here, okay, each shell, okay, gets farther away from the nucleus. And if an electron falls from one of the larger shells, the ones further away from the nucleus, that will emit a photon, okay, if it were to fall to a lower energy level. And if, the electron moves up, so it goes from, an energy level that is close to the nucleus and moves further away, that is increasing the energy level, which means that a photon is absorbed. And so like I briefly mentioned, the quantum numbers is an important aspect of this chapter. So you're looking at N is the number of the energy level, okay? So N equals 1, N equals 2, N equals 3, so on. L will be the shape of the orbital, so either S, P, D, F, etc. These are kind of the basic ones that we deal with regularly. And they each have a different shape. This one's just, circle, this one's more dumbbell, D is a flower, and F is a little more complex of a flower. Then we have M, okay, the first M, is the magnetic or orbital subtype quantum number. Then you have MS, which is the spin, a positive or negative half. Will represent the spin of that specific electron. And these quantum numbers are basically used to be able to identify specific electrons in an atom, okay? Some other words you might hear used in this chapter. So free radical is an atom or a molecule with an unpaired electron. Then you have diamagnetic, which means that all electrons are paired, and there you will see some repulsion. Then we also have paramagnetic, which is when you have 1 or more unpaired electrons, all right? So next, if we head over here, we have more of the equations and the important constants that we need to remember. So Planck's constant is represented by the letter H, and it is 6.626 times 10 to the negative 34 joules times seconds, all right? Then we have the speed of light, which is 3.0 times 10 to the 8 meters per second. Then we have some equations that are kind of important for this chapter as well. So you have E equals hf, which is Planck's relation to frequency. So you have the energy equals Planck's constant times the frequency. Then you have L, which is the angular momentum, is nh over 2 pi, is another equation. Then you also have E equals negative RH over n squared, which is used for the energy of an electron. Then you have E equals hc over lambda, which is Planck's relation to wavelength. So you have E equals Planck's constant times the speed of light divided by the wavelength, okay? Then we have this equation right here, which is a little more complex, but it's used to determine the energy of an electron in transition. So when it's transitioning between those different n energy levels like we spoke about. So that one is actually E equals the energy of the electron in transition equals negative RH, the absolute value, 1 over n squared, the initial n, minus 1 over n squared for the final energy level that it is on. So I'm hoping you can see. Let's just move a little closer so you can see that one. But that is, like I said, for the energy of an electron in transition. All right. Then we have the max number of electrons in a subshell will be 2n squared. And the minimum number of electrons in a subshell will be 4L, which is the quantum number that we spoke about earlier, plus 2. All right, and then our final equation here is frequency. So frequency equals the speed of light divided by wavelength. All right, so again, even though this is a very general overview, there are other videos that you can search up if you need a more in-depth version, but this is basically a recap of this chapter, as well as the important equations that you should be able to take out and will be useful for the rest of your MCAT studying, all right? So if you have any questions, please put them below. Otherwise, we'll get into more, detail of all of this in general chemistry in the next couple videos, so I will see you there.